Hello, fifth graders. It's Wednesday, February 17th, and I have a whole bunch of fraction problems that hopefully you have already solved, and now you're just checking with me. Maybe you thought I had some typos on these first two lines. What is this addition and subtraction you ask us to do? Yes, I of course am still going to expect you to remember how to add and subtract fractions. So the bell work is a perfect opportunity to review that. So for number one, I have 1 4/5 plus 5 2/5. And when you're trying to add fractions, remember, you need to have the same size pieces, right? And the denominator tells you how big the piece sizes are. And look at, those are both the same. Yay! So you don't have to change anything. I can just add my whole numbers together. So 1 plus 5 is 6. And then we can add our numerators together. So if you have 4/5 plus 2/5, 4 plus 2 is 6, and we don't add the denominator tells me how big the pieces are. It always stays the same. Now, maybe you're thinking you're done, but we're not, because 6/5 is improper, right? That means we can't leave that. That's not simplest form. So I'm going to change this 6/5 into its mixed number version. If you have 6 out of 5, that means you have 1 and 1/5, because 5 goes into 6 one time with 1 left over. So we're done with that. Now we can just put these two together to get our final answer. So if you have 6, and then you have another 1 and 1/5, that means you have 6 plus 1 is 7 and 1/5 for your final answer. All right, take a look at number 2. Again, I check to see are my denominators the same, and yes, they are. They won't always be, but for the first line, I thought, why not? So my whole numbers, I just have a 1. 2/3 plus 1/3, if you have 2 out of 3 and then another 1 out of 3, that means you have 3 out of 3. And this is not a simplest form answer, because 3/3 is equal to what? Yes, 1. I heard you say it. 1 plus 1 is 2. So you should have 2 for number 2. I didn't even do that on purpose. It just happened. For number 3, the denominators match. So I'm going to add my whole numbers. 5 plus 3 is 8. And then 1/6 plus 5/6 is 6/6. And again, 6/6, if you have 6 out of 6, that means you have 1. And 8 plus 1 is 9. All right, now in the next row, it wasn't quite as nice. We don't have matching denominators. And it's our job to get matching denominators before we can add anything. I can't just say, well, 3 plus 1 is 4, and 8, 9, 10, 11, 4 11ths. That's not how it works. If you have 3/8 and then you add 1/3 to that, you can't do it the way it is, because the pieces are not the same size. Okay, think about pizza. If you were going to be sharing pizza with people, wouldn't you want to make sure, like if you each got one piece, that those pieces were the same size? Yes, so it's kind of that same idea here. All right, so remember, your first step is to see, can I multiply the lower one by something to get the higher? And I can't do 3 times anything to get 8. So we learned that we can go ahead and multiply each fraction by the opposite fraction's denominator, right? So that means I'm going to multiply 3/8 by 3/3, and I'm going to multiply 1/3 by 8/8, and rewrite some new fractions here. So 3 times 3 is 9, and 3 times 8 is 24. That's what my equivalent fraction for 3/8 is going to be. And 1 times 8 is 8, and 3 times 8 is 24. Now do you see how they're both out of 24? Yes, we can add them now. Our denominator, that's the piece sizes. That doesn't change. You just leave it the same. So if you have 9 out of 24 and then another 8 out of 24, you now have 17/24. And there's not a number other than 1 that goes into 17 and 24, so you're good. All right, look at the next one. I can't multiply 4 by something to get 5. So I'm going to get a common denominator by multiplying each fraction by the opposite fraction's denominator. So 1/5, I'm going to multiply by 4/4. And 3/4, I'm going to multiply by 5/5. When you do that, do you see how you have the same multiplication problem on the bottom? That's what gets you the common denominator. When you multiply each fraction by the opposite fraction's denominator, you get the same denominator. So now the top, 4 times 1 is 4, 3 times 5 is 15. Now we can add them. If you have 4 out of 20 and then another 15 out of 20, you now have 19 out of 20. Don't change the size of the pieces. The denominator never changes. And 19/20 is in simplest form. Okay, for number 6, I have 2/3 minus 1/9. And again, my first question I always ask is, can I multiply the lower denominator by something to get the higher? And in this case, you can. So maybe you have a denominator of 27 maybe you multiplied this by 9/9 and this by 3/3, and then you simplified at the end. That's fine, but you could have multiplied this one by 3/3, because in doing that, you would get 6/9 and minus 1/9. You wouldn't have to change that. So then you'd end up with 5/9, and you wouldn't have to simplify anything at the end. It makes it a little bit easier if you could recognize that. And if you didn't and you had 15 27s, then you would just go ahead and have to divide each by 3. So if you did write 15 out of 27, those are both divisible by 3. So you should have divided by 3, and 15 divided by 3 is 5, and 27 divided by 3 is 9, and there's your 5/9. Okay, now finally we're down to multiplication, and maybe you've come to appreciate multiplying now. You're like, oh yeah, I remember how long those other ones took. I like these so much better, because all you have to do is see if you can cross simplify, which I can't for this one, and then you multiply across the top. 2 times 2 is 4, and multiply across the bottom. 5 times 5 is 25, and you're done. If you wrote 4/10, that means you added the 5s on accident. This is a multiplication problem, so multiply them out. For number 8, I have a mixed number, so I'm going to change that. 9 times 1 is 9, plus 5 is 14/9 times, I don't have to change that one, it's all set, 3/7. Now, you could do 14 times 3 and 9 times 7, but you don't have to. First off, I see this 9 and 3, and I know that 3 divides into both of those. 3 goes into 3 once, 3 goes into 9 3 times. And then I see 7 and 14, and I know that 7 divides into both of those. 7 goes into 7 once and into 14 twice. So now all I have to do is 2 times 1, which is 2, and 3 times 1, which is 3. So I get 2/3 for my final answer. That's it. Maybe you're thinking, well, how is that less than 1 and 5/9 when I'm multiplying? Well, I'm taking 1 and 5/9 3/7 of a time. 1 and 5/9 one time would give me 1 and 5/9, but isn't 3/7 less than 1? So I'm taking 1 and 5/9 less than 1 time. Hopefully that makes sense. Yes, you're going to get a lower value. Okay, for number 9, I see a mixed number. We need to change that because it's multiplication. 4 times 3 is 12, plus 1 is 13/4 times 12, and I'm going to pop a 1 underneath that. Okay, now you might be thinking, 13 times 12, what? No, you don't have to. See this 4 and 12? 4 goes into both of those. 4 goes into 4 once, 4 goes into 12 3 times. So now I have 13 times 3 over 1 times 1. So 13 times 3, yeah, we're going to have to multiply that one out. And you could do that by maybe repeated addition, 13 plus 13 plus 13. Or maybe you did 3 times 3 is 9, and then 3 times 10 is 30, and 30 plus 9 is 39. Fine. Or maybe you just set it up and you remembered, okay, I can set it up like this, and I do 3 times 3 is 9, and 3 times 1 is 3. No matter what you do, whether it's repeated addition or breaking that apart using the distributive property or standard algorithm, you get 39. And 39 divided by 39 divided by 1 is 39. So 39 should be your final answer for number 9. Thank you so much for checking your work. Great job.